Now we're going to look at something a little bit more complicated, which is what happens when you multiply or divide quantities. What do we do with the uncertainties? Well, in this case, we totally disregard the absolute uncertainties. We're not going to use the absolute uncertainties as we did in the previous section when we were adding and subtracting. And by absolute uncertainties, I mean this, which is expressed as a unit. This is an absolute uncertainty. When we are multiplying and dividing, we have to use fractional uncertainties or percentage uncertainties. Now, the rule is the following. When you are multiplying or dividing quantities, then you must take the fractional uncertainties and add them up. And that will give you the final fractional uncertainty for your result. In terms of the notation, it looks like this. Y equals A times B over C. The fractional uncertainty in Y, which is delta Y over Y, remember, this is the absolute uncertainty, so the fractional would be delta Y over Y. The total fractional uncertainty would be equal to the fractional uncertainty in A, the fractional uncertainty in B, and the fractional uncertainty in C. Your final absolute uncertainty would be equal to delta Y. Okay, let's have a look at an example. It might make things easier. You can also do this with percentage uncertainties. That means that the percentage uncertainty in Y would be equal to the percentage uncertainty in A, percentage uncertainty in B, plus the percentage uncertainty in C. Note that we are adding even though we're subtracting the quantity. So let's have a look at this example. Here we have two readings, one for distance and one for time. We are trying to find the average speed, so that's why we need those two measures. The average speed is equal to distance divided by time. So we're going to be dividing these to get the final average speed. The absolute uncertainty in distance is 0.02. The absolute uncertainty in time is 0.07. So how do we now find the absolute uncertainty in speed? Well, the first thing we need to do is actually work out the speed. An important part of this whole exercise is that you're still doing a calculation, right? So the first thing you need to do is to take your distance and your time and work out speed from it. Speed equals distance over time. And as you can see here, the calculation's done for you. It's 0.66. That is the speed. So we've got that part of the problem solved. But now we need to find the plus and minus bit. We need to find the uncertainty. Well, if you remember, the rule is that when you are multiplying or dividing quantities, you add the fractional uncertainties, right? So we're going to add the fractional uncertainty of distance to the fractional uncertainty of time, and that will give us the fractional uncertainty for speed. And here we can see 0.02, which is the absolute uncertainty, over the measure 0.83. That gives us the fractional uncertainty in D, plus 0.7 over 1.25. That gives us the fractional uncertainty in T. We add them up to give us 0.08. So that is now the fractional uncertainty in S. So basically, what we have now is delta S, the absolute uncertainty, over S, which is the value of speed, equals 0.08. So if we rearrange this now, we have delta S over S, which is 0.66, equals 0.08. And as you can see, delta S is equal to 0.08 times 0.66, 0.05 meters per second. So what we have now is 0.66, our value of speed, plus or minus 0.05 as the absolute uncertainty. So I'm hoping now you've got a clear idea of the difference between fractional and absolute uncertainty, and you have a clear idea of how to add fractional uncertainties to then give you your absolute uncertainty.